Alright, let's get started with today's problem. Also, I apologize for the background noise. It is just incredibly hot in Southern California right now, so I can't really do much about that. In any case, our first problem of the day is going to be LeetCode number 528, random pick with weight. You're given a zero-indexed array of positive integers w, where wi describes the weight of the ith index. You need to implement the function pickIndex, which randomly picks an index in the range 0 to w length minus 1 inclusive and returns it. The probability of picking an index I is the weight itself divided by the sum of the weights. For example, if w is 1 and 3, then the probability of picking index 0 is a fourth, and the probability of picking index 1 is 75. Okay. Then let's see. So, let me think about this. And we are given an array of values. So we could probably cache the sum of the values. And then return, well, here's the thing, right? We need to pick the amount. I think what sucks about this is that I've done this before. I've actually done a similar problem to this, not like actually on LeetCode, but purely on my own, because I've been involved in a project or two, and we've had to implement essentially loot boxes, right? And those loot boxes usually have weights on what can be awarded to the player. So this is a really interesting problem. If I recall correctly, what we did is that we had a weight, and then we rolled an initial value, and then we started subtracting. So roll an initial value, and then go down the list of items, of weights rather, and if the value is less than that amount, we pick it, or something like that. Otherwise, was it we subtract? So for example, for 1 and 3, we would do sum is equal to 4. So then we'd say roll a number between 0 and 4. Or sorry, 1 and 4. And then we'd say if the value is greater than, say, 3. Sorry, if the value is greater than 1, maybe, then we say that we would pick, sorry, go from the max weight to the min weight. And then we'd say, okay, if number is greater than or equal to 3, which in this case, well, greater than 3, right? So current weight, then subtract the amount and continue. So we'd say, okay, we start rolling a number between 1 and 4. We can get 1, 2, 3, or 4. And of course, 1, 2, and 3, because they are less than 3, then they will count as picking 3. And if we roll a number that is lower than, higher than 3, in this case 4, then we would say subtract 3 and go to the next one, which is 1. Let's see if this actually works, and extending into future values. Let's do like a 1, 2, 3, 4, where the sum is 10, I believe, for this. 7 plus 3, yep. So roll a number between 1 and 10. So let's say, example, we roll a 6. Or let's say we roll a 10. That rolls down to a 6. That rolls down to, or let's just start with each. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A 1 would roll a 4, same with 2, 3, and 4. Right, because they're all equal. 5 would roll a 3, 6 would roll, let's see, 5 minus 4 is 1, that's 2, that's 3. Then 8 minus 4 is 4. 4 minus 3 is, or 4 is greater than 3. So that would leave us with 1. So that would be 2, 2. And then we do 4 minus 3, so that's, 10 minus 7, that's 3. 3 minus 2 is 1, and then we're left with 1. Okay, so that seems to work. Works. I think because we have 4 out of 10 chance to get 4, 3 out of 10 chance to get 3, 2 out of 10 for 2, and a 1 out of 10 for 1. Okay, so I think this actually works. So we'll get a sum is equal to w.reduce. We will start with a 0 and then accumulate function, which has an accumulator and our num. And we'll say accumulator plus equal num. And then we'll say, well, we need to kind of sort the values, don't we? So that's kind of, in that case, we kind of need to do an O of n log n to sort the values if we wanted to do this. If we wanted to go from highest weight to lowest weight, because we don't really know necessarily that this is in order. So we kind of need to do this on our own. So we'll also do a w.sort as well initially. And then we'll say var initial value is equal to, is there a random function in Kotlin? Random is here. We want to do a math.random. Can we do a math.random? Let's see. Random.nextInt. Can we do from and until? Okay, yes. So we can do, well, we just want to generate a random integer. We don't, let's see. Next until, okay. So we do random.nextInt from 1 to w.length. And then we'll say while initial or current value is greater than our, we'll say var current index is equal to w.length minus 1. And this is size, not length, because we're dealing with a collection, not a string. While our current value is greater than our w at current index, current value minus equals our w at current index, and then our current index minus minus. And then we just return our w at current index, and that will return our value. Return the value once we cannot go any further with our size. And actually this should be not between 1 and size, it should be 1 and sum with our current value. And then we just keep on cutting that down until we hit the bottom. And our current index starts at the last value and goes down all the way until 1. Or until, or current, while current value is greater than that, and our current index is greater than 0, because if it's at 0, then we just want to return that bottom value. Okay, so this runs in O of n log n time because it's kind of bounded by our integer array. Of course, we could also consider using something like bucket sort, radix sort, which may be faster than our traditional quicksort methods and is applicable for this because we're dealing with integers. But for now, let's just assume that our sorting is O of n log n time, and let's hope that that's fast enough. We know that the length of our array is at most 10 to the 4, which seems to suggest that an O of n or an O of n log n time would suffice, but I'm not entirely sure with some of these LeetCode problems. They can be a little bit tricky, I think. But yeah, this is an interesting design question. I'm always interested in these sort of design questions more because I think they tend to sort of lean towards a more practical approach in terms of solving a problem that you might encounter. And this is something that I've actually encountered before. Like I said, programming up loot boxes for a game a long time ago, actually. I'm surprised I still remember kind of how it works, though I'm not entirely sure if this will be bulletproof. Anyways, let's see. Let's just double check our functions. So we start with our sum, and then we will go into our pick index function. And this is, we start with our last value. We generate a random integer between 1 and our sum. And while this value is greater than our current index, then we will subtract the amount and go 1 lower. And then we'll return whenever we break out of this. I think that makes sense. Let's go ahead and run the code and let's see if there are any issues. Let's see, wsort, They probably want us to do, well, this might need to be in an initialize block. So it's not liking that. Literal does not conform to the expected type. Let's see, how do we use this reduce again? This reduce function is really cool, but it's, let's see, some element. Okay, cool, so we don't need to actually start it off with anything. I think that might be a Java thing then. Accumulator cannot be reassigned. Well, I think it should be able to now, right? Yes, at least it should be. And then, let's see, what else? Oh, no, because we want to return that amount, right? It should return an int. Yep. Okay, and w size -1. W should be a thing. Well, we can create this, we can make this a value, and then it'll be a thing, right? And that won't significantly change anything. That just means that we insert our the value as a field. It's still not happy about this, which I am not sure why. Is sort the one that does it in place, or is sort the one that returns a value? Let's see, sort. Sort does it in place. Not sure why this isn't happening. Let's try to throw it inside an initialize block to see if it's happy about that then. Because we need it to sort. And then it's not happy about this next int implementation. I think it's because this LeetCode Kotlin does not implement any of the extension methods. So let's go ahead and use Java instead. I think Java should be able to help us here. So we want next int, and our bound, let's see, between 0 and our specified value exclusive. So let's do that instead. Let's do let's see. Should be able to do next int actually, because that's still the same method. Here, current value minus equals. let's see. Assignment operators ambiguity is equal to current value minus that. Next int. Why is next int not working? Well, what if I just throw it in as that then? Still not happy about that. Okay. Do I need to generate a new random in order to do this? Math.random simpler to use. That is true, but can I? That's generated between 0 and 1. Let's just do a random is new random. So let's do a val RNG is a new random. And then we'll do here we'll do RNG dot next int between 1 and some. And this is because it's in Java, so now we can only specify an upper limit. So we'll specify an upper limit of sum plus 1 because this is exclusive. Actually, no, we want it exclusive between 0 and sum, or sum minus 1 then, because those are the values that will be generated, and plus 1 will carry it over. So that should be correct now. And we'll just generate this RNG seed once, or yeah. Let's see. So theoretically, it should generate the same seed every time. Let's do a print line at our current value, and let's see what actually comes up. Oh no, it's because we want our current index, not our actual value, right? We want to return the index, right? So let's go ahead and do that. I was like, is the seed wrong? Do I just need to keep on hitting submit until it works? Alright, let's go ahead and submit and let's see if it's fast enough. This O of n log n is kind of scaring me, but I assume that because the input is 10 to the 4, it should be doable. Looks like we're not quite in the range of... Looks like we're not quite averaging properly. Let's see. So what is the actual 3, 14, 1, and 7? 3, 14, 1, and 7. If we sort this, this should be 1, 3, 7, and 14. This would be 10 plus 4 or 10 plus 15, so sum of 25. So then we should have a let's see. So we should have a 14 out of 25 to hit this, 7 out of 25 to hit this, 3 and 25 to hit this, and 1 and 25 to hit this. But it looks like we're hitting actually a crazy amount of 3s. Rather than sort of the distributed way of doing things. I wonder why. The current value. Let's like do a smaller version of this. So solution, then pick index, 3, 4, 5, and then it's 3, 14, 1, and 7 was the original. 2, 3, 5. Number of constructor arguments should be 1. Oh, this needs to be wrapped in another set of brackets. Interesting. Okay. It's working for that, but it's not working for the long-term ones, which seems to suggest to me that our RNG is somewhere is off. So we pick a number between 1 and 25. Then we would do, so let's see, 25 to 14. Would it be 25 to 14? Let's see. It would be 1 to 14 would be 14. Then, so 1 through 14 would hit 14. Then 15 through, let's see, 15 through, what's 21, I think would hit 7. Because, yeah. Then 22 through 25, let's see, 24 would hit 3. Let's see, 1 through 14 would hit 14, then 15 through 21 would hit 7. But this should be 22, right? No, 21. Or it should, let's see. No, this is fine. Then 22 through 24 should hit 3. That's also fine. Then 25 would hit 1. This should be fine. I don't know what's going on here. But we're hitting we're hitting a pretty wild number of 3s. Oh, it's because it's the original index. Oh, right. Okay. How do we want to do this then? Right, because it's the original index. Do we want to map it? Then we would use O of n space. I'm not sure if there's any other way we could do this. So if we do a val map is mutable map of int to int. So this is here, so, and we do var sum is equal to 0, and then we do here before the sort w dot for each number and index. We do map dot put index into, and this should have a unique value. This should have a unique set of values, right? Because otherwise it would be kind of weird. Let's see. How do we want to do this? Map key is, the key is going to be the weight, maybe? And the value will be the index. If we did that, so the idea is that once we can reach a value, and then we want to find the original, let's see, original index map, we'll call it, then original index map dot put in, we want to put our number, our weight, and then our index there, and then we want to do sum plus equals num, and then we want to do original index map of our current our w at current index, I think is what we want. This might be slow though. I mean, this is still O of n. I don't think we can go beyond that. This should be a get value, and that will return a 0 in case that doesn't. But this should always hit something. This should W at current index. Yeah, that seems to work a little bit better because we need our original index in order to hit those values. But yeah, if this is too slow, then we probably can't. If this is too slow, then we probably can't use our sorting method and go from largest to smallest in that case. This is the wrong answer. Looks like we're not hitting any zeros. Interesting. Oh, it's because there's 2 of them. Okay. How do we want to do this then? If we have an equal chance to hit both of them of 10, let's see. Because if we've hit them, yeah, how do we deal with duplicates then? Let me think. Dealing with duplicates, that's a little bit tricky. If we did the original index instead, what would happen if we used the original index? Because at the same time, after we sort it, we don't know. We don't know exactly where we end up, right? When we sort it, we don't know which 10 is which. So maybe we can't sort. And in that case, what can we do? Is there anything that we could do with the original values instead? Like if we had this like 3, 1, 2, 4 situation where we had a sum is equal to 10. I mean, I don't want to create a method that is the length of the sum, then we can't because the maximum weight can be 10 to the 5, right? So that would be an untenable situation. So we don't want to do that, and we don't want to do that. What can we do instead, though? If we assigned each, if we created a data structure, if we created a data class item, which has a value of weight and a val weight and a val index, and then we said we wanted to do, so for each one then, so we'd store all these values independently, and then we do a item map or item list is equal to mutable list of item. Let's make this capital I, item. We don't really need this, I don't think. And then what we'll do is that we'll do our item list dot add. We'll create a new item which will have a weight of num and an index, its original index, and then we'll add the sum, and then we can do here, we can do item list dot sorted by, and we can say item dot weight, I think, for each item. I think that works. Well, it looks like it compiles fine. Okay, that's good. So now the next step is to actually use this. And we'll say our current weight is that's fine. And we want to use our item list. We want to actually use our item list. So now we can move this W back into non-existence. Constructor with a W, which is an int array. Or can we just do this? Because this should have a an int array inside. It's constructor. And then we want to use the item list dot size is greater than item list at current index dot weight. List, and then we want to return our item list at current index dot index. Let's see, constructor. If we did a constructor, is this part, can we just get rid of that? Is it fine to just have reference this W in our constructor? Or do we need maybe init? But no, I don't think this actually has a reference to that W. We'll see. Okay, so it looks like it does have a reference to that W, so we're fine. And then now, after we sort it, we still keep track of the original indices using this data class. So now we know exactly which index they were originally from, and since each index is unique, we won't have a trouble with that. Okay, so that works. It's a little bit on the slow side. I'm not entirely sure how I could speed this up even further, but this is sort of a basic idea of how the weighted picking random works. Basically, we roll a random weight between 1 and the sum of our weights, and then we go down the list and we say, okay, does this one work, does this one work, or is this one greater, this one greater, this one greater, and then we just keep on subtracting until we get to the point where we can't subtract anymore, and that produces our weight. I can't exactly remember which resource I got this from. It was some like Unity like weighted RNG kind of thing, kind of video on YouTube. It was pretty useful actually, and I'm surprised I still remember parts of it. But in any case, that's sort of how we do it at a very high level. I hope you learned something, and I'll see you for the next problem.